All right, so let's move to the next topic, which is cryptocurrency. And the first thing is to understand blockchains and set up a wallet, and then we'll start making smart contracts and seeing the flaws in these smart contracts. So the first thing here is the blockchains, and there's a nice simple online demonstration of blockchains here. That lets you understand how they work. So this blockchain is a special case of a Merkle tree, which is designed by a mathematician named Merkle, and it works like this. You have a block of data, so I can put data in here like Sam wins 10 coins, and whoever mines this block will win an award. So you have a nonce, which stands for number used only once, and you can change this number to anything you want, and the hash value of all this data is currently this number starting with F72. And mining consists of just changing this nonce to a random number until you get a hash that starts with a lot of zeros. And the number of zeros required is the difficulty factor, which is adjusted. So now it's done mining and it turns green. And you see it starts with 4 zeros. So 4 zeros is the difficulty of this blockchain. And so this was mined by Sam, and when you do the mining, you win a reward. So the next block, maybe Sue will mine this one, and she will win 10 coins. And other things will happen, like Sam sends Jerry 2 coins. So you have data in here. These are the transactions, and you have the mining reward. And so Sue mines this one. And when she does, it turns green and has a hash value starting with a lot of zeros. And this block includes the hash from the previous block. So if anybody tries to cheat, like Sam tries to change this to 100 coins, this block no longer has a proper hash value, and the next block no longer does. So if you verify the latest block, that means the whole chain must be intact up to that point. That is the point of this. So it's very easy to verify. And the purpose of this is to create a database where everybody has write privileges and nobody can change anything in the past. So anybody can send transactions to the network, and the miners just pick these transactions off the network and put them in a block and mine them. And after a block is mined and the hash value is added and a few more blocks are mined on top of it, it is considered irrevocable, and that's a permanent record of the past. So the point of the blockchain is you don't need a central authority anywhere, like a bank or a government. There are many miners scattered throughout the world, ideally, and they are hopefully separate and not collaborating. So the miners verify each other's work. And the miners are motivated by this coin reward and also by the tips. You can add an extra tip for your transaction, and you need to, because there's a lot of transactions out there in Bitcoin and Ethereum, and you have to motivate the miner to mine your transaction. The miner is under no obligation to include all the transactions. So they will pick the transactions that give them a higher tip, and that's the transaction fee. And so the transaction fee floats with demand, and that is a problem. The Ethereum transaction fee rose up to like $100 a couple of years ago, so it was very expensive to do transactions, and it's always pretty high on Ethereum. So this, what I've described here, is really Bitcoin. Now Ethereum adds code to this. In the block you have code, which is called a contract, and then you have data, local data that goes to the code, just on the blockchain. And when you go to the next block, it's going to calculate the next step in the code and change the data, and it'll be changed as you move forward. If their code is executed, it will change the data. So, and it mines the same way, or at least it did until this week. It would mine and mine, and so all this data was also irrevocable and recorded forever on the blockchain, but you could now have a contract that manipulated the data on the blockchain. Now, the change this week was the change from proof of work to proof of stake. Now, what I've described here is proof of work, where all the miners are competing to find a hash value. And what they do is they make this so difficult that you have to guess millions and billions of times to find a hash that starts with that many zeros, and that all the miners have the fastest computers they can possibly make with the most power they can possibly afford to get in the country that sells power for the cheapest. And they run these miners to just try random numbers until they get a winning lottery ticket with enough zeros here, then they win and get an award. And that's the problem. Bitcoin is using a ton of energy. It's using 0.1% of all the world's energy just to do this Bitcoin mining. And Ethereum was using a lot too. So people got tired of that, and they switched this week, finalizing on the 15th, 2 days ago, to proof of stake. So instead of fast computers competing to mine the blocks, you stake some money. You take some Ethereum and you deposit it in an account where you cannot withdraw it, and that is your stake, like a stake in a card game, and that stake gives you a chance of being awarded the privilege of mining the next block. So the more you stake, the more you have a chance of mining the next block and earning an award, and that money is frozen. And if you cheat and lie about mining the blocks, they can impound your stake. So this is moving us, and it turns out, in fact, that almost all the mining is being done by just 2 or 3 companies, one of them being Coinbase. So really, this move from proof of work to proof of stake has turned Ethereum from a decentralized system to a centralized system. Really, all you're doing is doing business with just a couple of central agencies like Coinbase. And that may have legal consequences because the Securities and Exchange Commission says it used to be a commodity when it was just distributed all over the place. It was something like gold or corn that you're selling on an open marketplace, but now that you've switched to proof of stake, it really is just going to a couple of major players. So essentially you're buying stock in Coinbase. And that will change the legal requirements if that's true. It will also make it easier for the government to regulate it, tax it, enforce sanctions on forbidden nations and such. So it will move cryptocurrency back to being very much like other forms of currency like Visa and MasterCard and the dollar and the euro, where it's controlled by a central agency and subject to the laws of a certain country. And a lot of the cryptocurrency enthusiasts feel like that ruins the whole value of it. But anyway, Ethereum has done it, and technically Ethereum is still running. In fact, some of my projects were messed up because some of the Ethereum test nets were not working a couple of weeks ago, but I just tested and they're working now. So the merge caused some chaos in some of the test nets, although it did not stop the main net that's worth real money. And it seems to have gone fine. So from a viewpoint of a user or a developer, Ethereum is still working just the way it always did. The philosophical purists of cryptocurrency have an argument about the new system, but anyway, it's working. So that's how it works here. And you've got some flags to find using that simple test blockchain here. And then when you're done with that, or if you skip it, you can go to the real blockchain, which is the Metamask Wallet. And this is what everybody uses. They have this browser extension that you put in any Chrome or Chrome similar browser called Metamask, and you can create a wallet here. And when you create a wallet, you'll have a key. So let's see, I don't think I have one on this browser. Well, I've already made one on my other ones. Anyway, the point is you just go through the normal steps to make a browser, and you'll have a secret backup phrase, which is 12 or 14 words. That is your master secret key. Anybody can get your money with that key. That's what you should save somewhere and print out and put in a safe and never tell anybody. And with that, you can recover your money from anywhere, from any computer. That's your master key. And then you'll have an account. Your account will start with no money on the Ethereum mainnet. Now, all my projects, of course, do not use the Ethereum mainnet because that either costs real money, and none of my students are spending real money to do projects, but there's a bunch of test nets available, which are free coins that you can use to develop your contracts and learn about Ethereum without having to pay any money. So one of the newer ones, which was working even during the merge, was Sepolia. So to join Sepolia is so new it's not integrated with MetaMask yet. So you have to add a network and then enter certain values. To join a network, you need a RPC, or remote code, I think it should be RPC. Yep, RPC, I got to fix that. Remote procedure call URL. Somebody has to be running a node to take requests to get data from the Sepolia network. There has to be some public nodes, and this is one of them. rpc.sepolia.org, and this chain ID number has to be right, and that's the number for Sepolia. And there's a block explorer, so you just have to fill in a little form with these facts, and then you can connect to the Sepolia network. Now you still have no coins, so you have to get some coins, and there are faucets that just hand out free coins on the test nets, And there's a variety of these faucets here. Some of them require you to tweet the address. Some of them require you to work for a while mining in your browser. And eventually you'll get some Sepolia. Like you see when I did it, I got 2.6 Sepolia. And then you can send me some Ether and the Sepolia network. Let me see if that works. Here's my browser that I've set up for this, and here I am. I've got some Sepolia, and I'm pretty sure it's working, but it's a good thing to test it. So once you've got some Sepolia, I can send it. So I'm going to send to this address, and I'll send a small amount, 0.01. Doesn't have to be much. Now when you send, you hit next, and it's always going to cost you a gas fee to do everything. So it's my gas fee is 0.0000032, a tiny amount, but there's always a fee for any transaction on the blockchain. And so I pay for that, confirm it, and off it goes. Now the Ethereum blockchain, the Bitcoin blockchain takes 10 minutes to send data, but the Ethereum blockchain takes only 15 seconds between blocks. It's much faster. So we should see it. It's pending. Now, when I tried this on some of the test nets a week or two ago, it would just sit there pending forever. The blockchain had frozen up, which, see, it finished right there, just in a few seconds. So the Sepolia network is working just fine right now, which I'm glad to see. And so is the Ropsten network, which was not working at all a few weeks ago. So all my projects should work as intended, and that's a good thing. So set up your Metamask and get some Ether, and then we'll make a smart contract and deploy it to a test chain, but that'll be a separate project. I'm going to stop this.